So we just finished talking about symmetry in functions, but now that we're done with that, we can move on to a different notation for that, or a different vocabulary for it, and those are even and odd functions. And you should have learned about this in math analysis, but the idea is simply this, that when you have a function that has y-axis symmetry, it's called an even function. And using function notation, we can actually say something a little bit more specific about that. What we can say is this right here, that f of negative x is equal to f of x. And specifically what that means is, if you have an even function, in other words a function that has y-axis symmetry, plugging in negative x is exactly the same as plugging in x. So if you have f of negative x, it's the same thing as having f of x. A place that you've certainly seen this before is think about the function x squared, which is an even function, right? What happens, like if this is your f of x, what happens when we plug in negative x to that thing, right? We end up with negative x squared, which is x squared. Notice that when I plugged in that negative x, I got back the exact same thing as when I had just the original function by itself. Right? In a very similar sense, when a function has origin symmetry, which was the other major symmetry we talked about in the previous video, that function is called an odd function, right? And we've got a similar thing we can do using function notation. When you plug in negative x to that function, it's the same thing as having the opposite of the original function. Again, we've seen this before. If you have a function like f of x equals x cubed, when you plug in negative x, f of negative x, you'll have negative x cubed, which becomes negative x cubed. Notice that this is precisely the opposite of what the original function is. So that's a property of odd functions, in other words, a property of functions that have origin symmetry. Now, keep in mind, a very, very important note down here at the bottom, just because all numbers are even or odd doesn't mean functions are even or odd. You will have some functions, in fact a lot of functions, that are neither odd nor even. So you can't test these things and just say, oh, well, it wasn't even, that means it must be odd. Not at all. A function is even or odd or neither one of them. Okay? Now, I'd like us to give a little bit more attention to these two formulas, because there's actually a lot more behind them than just what you see there, right? I want you to think for a minute about an even function. In fact, I'm going to remind you of a very specific even function. Let's look at and think about the even function y equals the cosine of x. Now, you may not have realized that that was an even function, but think about what the graph of cosine x looks like. Alright, so here it is. This is an even function. It's a function that has a y-axis symmetry, right? This little formula up here says, effectively, that if we plug in a negative x value to the function, we'll have the same thing as if we plug in the positive value to the function. Well, we'll take a look at that. Think about what f of 1 is. F of 1 is that height, and f of negative 1 is also that height. Notice those are the same things, right? F of 3 is that value. F of negative 3 is that value. Right? I mean, f of 2 is that negative value. F of negative 2 is that value. This thing here is simply saying, hey, whatever you do on one side of the equation is going to be the exact same thing as what you do on the other side of, not the equation, but of the y-axis. It doesn't matter if you plug in a negative value or a positive value, you're going to get the same output value. And I hope you guys can see that. Like, I really want this class, I want calculus to be not just, oh, you know, yay, I memorized this formula, it's an even function, woo. Like, I want us to see what that's doing and be able to work with it. Okay? We can do the same kind of thing with an odd function. Let's take an odd function that we know about. Y equals sine x is an odd function, right? You may not have known that, but sine x, if you think about the graph, this graph has origin symmetry, right? I mean, it has that business of if we take the graph and rotate it 180 degrees, we end up with the exact same graph, which tells us, it sort of lets us know, hopefully I can get that kind of close to straight, lets us know that this function is indeed an odd function, right? So what does this statement say about the values in this graph? And if you're up for it, like, pause the video, see if you could understand and think about what this really says, right? What it says is, let's say that you took f of some negative x value, right? So that would be like, oh, you know, I plugged in negative 2, and this was the value I got back. This little equation up here says that should be equal to the opposite of what you would get if you plugged in the positive value. Well, sure enough, if I plug in positive 2, I get this exact same height. Notice this height is the same as this height. The difference is that one of them is positive and one of them is negative. right? And we see this everywhere, right? If I picked some other negative x value, if I picked like, negative 3.5, I get that. And if you look at what positive 3.5 is, it's the exact same value, height. The difference is that one of them is positive and one of them is negative, right? So we can see what these properties of these functions mean. Now I want to talk more about exactly what this means, right? This means if someone asks you what the cosine of negative x is, well, cosine is an even function, which means the cosine of negative x is exactly the same as the cosine of positive x. So you can actually just rewrite that as a statement. Like this can be turned into cosine x. So with that said, if someone asked you what is the sine of negative x, what could this be transformed into? Well, according to this statement up here, we should be able to write it as negative sine of x. Really, really powerful tools for when we're dealing with sort of complicated trig things. So let's go on and look at some examples of this. So a common example might be something like determine if this function, if g of x equals x sine x minus 3 cosine x, if that's even, odd, or neither. And the way that we go about doing that is we're going to plug in, we're basically going to look at what is g of negative x, right? G of negative x might be g of x, which would mean that the function is even. G of negative x might be the opposite, negative g of x, which would mean that it's odd. Or g of negative x might be crazy, which just means that it's neither. And then that's fine, that could happen, right? So I'm going to go through my function and I'm going to do g of negative x. Right? When I do that, I'll have negative x times the sine of negative x minus 3 times the cosine of negative x. And here's where I'm going to sort of use these properties. We saw in the previous slide that, sure, that's negative x. We know that the sine of negative x, because sine is an odd function, we can make this negative sine of x. Minus 3 times the cosine. Now we know that the cosine of negative x, because cosine is an even function, this just becomes cosine x. So then the last thing I can do is I can notice, hey, this is a negative times another negative. This will be positive x sine x minus 3 cosine x. Notice that this function that we got is exactly the same as the original function. Because of that, we can see that g of negative x is g of x, and that means that g of x is an even function. Okay? And one more example that might be more complicated, it depends on how you see this. I want us to prove that the product of two odd functions is always even. Right? And as soon as you see the word prove, a lot of you start freaking out and you're thinking like, oh my god, like two-column proofs from geometry. I'm never going to ask you to do a two-column proof again. And that's fine. It just means they're something we do in geometry, that's fine. To prove this, we're effectively going to need to show that every single time you multiply two odd functions together, you will always get an even function. Now you can't just do an example. You can't just go like, oh, well, I choose x cubed and sine x. That would show that those two odd functions make an even function. We need to show that every two odd functions will give you an even function. So what we're going to do is we're going to make up a function. I'm going to make up a new function called h of x, which is f of x times g of x. And over on the side, I'm going to state, like let f of x and g of x be what? Well, we want these two functions to be odd. So I'm just going to say, hey, heads up, those functions are odd. Let's look at what happens to h of x. Let's look at what happens to the product of these two things. Right? So how are we going to find out? How do we test whether a function is even or odd? And this is where you should be talking at your computer screen. Right? We plug in negative x and see what happens. When I plug in negative x, it means I'm plugging in negative x everywhere. Okay? Now, if only I knew what f of negative x and g of negative x were, like if only I knew something about whether those functions were even or odd, Wait a minute, we said that they were supposed to be odd. So because they're odd, we can use that property of odd functions. I don't know what h of x is yet, but I know over here that I can write this as negative f of x, and this as negative g of x. because f and g were both odd. But now I'm multiplying an odd by an odd, a negative by a negative, which means this becomes positive f of x times positive g of x. Surprise, surprise, that thing is exactly the same as what we started with. That means h of negative x will be h of x. And so therefore, what have we proven? Therefore, h of x must be even. Right? And I don't want to put a box around that because that really wasn't the answer. The answer was, hey, look, this is all the work that I did. When you're asked to prove something, you're going to need to show something. So we just showed that anytime you multiply two odd functions together, you get an even function. Okay? I'm going to ask you to do a similar problem in the assignment tomorrow, so just heads up on that. You'll see it again soon.